Hi, I'm Abubakar Siddiq Ango, Developer Evangelism Program Manager at GitLab, and in this video I'll be talking about security policies in GitLab. Security is no longer something organizations take lightly. It's now part and parcel of software development lifecycle in most organizations. And security teams in this organization are saddled with the responsibility of ensuring not just the organization itself and the network of the organization is safe, but also how the organization builds their applications. And one way they ensure this is to put in place policies that require security scans are executed anytime the applications are built or when the developers push their code, to ensure that those applications are safe and the changes that are introduced are also safe. Also, one other policies is to ensure adequate oversight over any vulnerability that is discovered during the security scans executed on the applications. Now, in GitLab, we have what we call security policies. And these security policies allows organizations to do set up two types of policies. One is scan result policy, which ensures that necessary approvals are required before a merge request is merged based on the result of security scans that are executed. Or let's say, for example, it's after a security scan, after the security detection scan has executed on the CI on the application, and it discovers a secret has been exposed newly. Now it can require approvals from security team or from engineering manager or from any other members of the team before the merge request can be merged. It can also just check and see, oh, a new license has been introduced into the application and it's not part of the license is approved to be used within the organization. Then it will require probably the legal team or another team, quality assurance or another team, to approve that merge request before it can be able to merge. Now, another policy that can be implemented is scan execution policy. So this ensures certain scans, security scans, are executed for the project or for projects within a group or subgroup. Now, this is important to ensure that even if developers within their applications do not put a CI job, the jobs that has been added to the security execution policy will be executed. Now, even if there's a CI script within a project already, and it doesn't include certain jobs that are required by the security team, they will be executed because they've been implemented as part of the scan execution policy. This allows the security team to introduce new security scan policies that keeps the application safe, even if the developers or new projects don't include those scans. Now, I'll be showing you a demo of how to create the security policies. Now, in my browser here, I'm in this group. This is a subgroup on GitLab. And within this subgroup, let me create a quick project. Let me just create from a template. Yeah, I can select any of the templates here. Let me just use Ruby on Rails. Now, let's see. Let's give it security policies. Now, let's make it a public project and I create. It's currently importing from the template. It's importing from the different project somewhere where the template is stored. Now, within the GitLab navigation here, we'll see secure. And under secure, we'll see policies. Now, when we go to policies, you can see it doesn't currently have any policy. This project doesn't currently have any policy. So we can create a new policy. Within this section here, if you have any policy that has already been attached to this project, you see them here and where their source is from. But in this case, we don't have any policy. So we'll be creating a new policy here. Now, like I mentioned earlier, we have two types of policies that can be created: scan result policy and scan execution policy. Now let's create a scan execution policy. Now within the interface, we have two types of mode. We can either use the policy rule editor within this interface, or you can write it manually yourself. But if you are new to this, it's best for you to use the editor. So let's give it a name: test security policy. Now, so you can add a description if you want, and you can either enable or disable a policy. Now, let's say for whatever reason you no longer need it, but you still want to keep the policy, you can disable it so it doesn't, or it's causing a conflict somewhere. You can disable. Now, you can select what kind of actions should perform, what kind of rule, what kind of action. We have the section for actions and we have a section for conditions. Now, the conditions and actions together make a rule, and you can only create a maximum of 5 rules. Now, let's create the first rule here. The first rule is run a SAST, static application security test. And you can select, probably within your GitLab instance or your GitLab group, if you're using GitLab SaaS, you have specific runners for certain things, or if for some reasons you have a runner that is secure somewhere or has some features that you've implemented that you want to run this particular job, you can add a tag. You can specify the tag of that runner uses to run jobs. You can specify it here. But here we just say select automatically. Then we can also add other criteria. Maybe you want certain CI variables. You want to customize the CI variables to add. You can do that. You can add another action. Maybe aside from SAST, it should also do secret detection. You should check our application for if any secret has been exposed. Constantly, it should do that. Now, then what are the conditions that should be met? So the conditions are, you can have two types of conditions, either triggers or schedules. Triggers are basically, anytime a merge or anytime a pipeline is running against a particular protected branch, then it should execute. You can either specify the protected branch or it should execute for all protected branch. For example, here, if we leave it at the condition at triggers, we can specify either all branches, default branch, all protected branches, or you want to specify a specific set of protected branches. So here I will just select all protected branches. These two actions should be performed against all protected branches. Let's say master or main, production, sandbox, any branch that we've protected, these scans should run against them. Now, then we can decide, we also want it to run based on the schedule. And anytime, and for schedules, you can either specify for the trigger to work with a branch or with an agent. If you've integrated your GitLab group or project or your instance with the Kubernetes cluster and you've installed the GitLab Kubernetes agent, you can specify that agent here for the scans to be executed against. Which means, for example, if you are using, you want applications that have already been deployed to your cluster to be tested, you can specify it there. But in our case here, we'll be using branch. Now, here we can also specify specific branch or all protected branches. It should run against them. But we can specify a branch name here, or let's just say the default branch. And we can set when it should execute, daily or weekly at this particular time. Now, so let's leave just the first condition for triggers. Now, the next thing is, okay, you've created your rules. This is an example of what it looks like in YAML. So if we switch to YAML mode, you see it has automatically filled it for us. So we are saying the type of policy we want to create is scan execution policy. The name is specified, there's no description, and the rules is it should be a pipeline and branch type protected. Actions, it should be scan should be executed SAST, and another scan should be executed secret detection. Now, if you are not used to the syntax, it's always best to use the editor like I mentioned earlier. So now to save this, you need to configure with a merge request. The way GitLab handles security policies is to store them in a security policy project, a separate project called security policies. Now, and when you click on this configure merge request here, it will create the project and give you a merge request to push this YAML file to the project. Now, the reason why it puts them in a separate project is so you can either use it for a different project or use it in a group or use it for any other project instead of just this one. More like repurpose it for other projects. Now, you can even decide to have created it already in a project and just add it to this, create it separately in its own project, then add it to projects themselves. Now, let's configure our merge request. Now, once the project is created, like I said, you can add it to as many projects, one to many if you want, or one to one just for this project. Now, you see, what it has done here is it has created a project and automatically is asking us to merge this policy that we've created to that project. And once you merge, you see it's the same policy that we saw when we were editing it earlier. Now, if we merge, done. We'll also notice that, okay, let me go back to my subgroup here. You see now, instead of, this is our project. Now it has created a new project. This project is automatically generated to manage security policies for the project, for this project. Now, once we go back to our project and we say secure, we'll go to secure, we'll go to policies, we'll see we now have this. This is our security policy, and we can see the details of the security policy here. It's going to run SAST, it's going to run secret detection, and so on. It's enabled. You can even see the YAML file. You can edit it. It will take you to the editor, and you can make changes if you want. So anytime we come to my project now, let's go to now you see our condition is every time a pipeline runs for this, you should add secret detection and SAST. So let's go to our repository here. I think we should have, a CI file. So let's check our CI file. What does it do? Okay, it has a SAST already. Now, if it has a SAST already, if a job already exists, it will run another one. Probably there are certain conditions or that the main one that in the policy has that this doesn't have. Now, so let's run our pipeline. Let me go to build and pipelines. And we can see here that there is no secret detection. So let's go to pipelines. Then let's click run pipeline against master and run pipeline. Now, you see here that we have secret detection. Then we have a couple, now you will notice that we have Brakeman SAST. Then we have Brakeman SAST 0. Now, the first one is the SAST job that the CI file itself has that it wants to run. Then the second one has a -0. It's the same thing, but with a -0. Now the -0 is the one our policy introduced. Then if we look at that of Node.js scan SAST also, we have 0 here and here. Same grep, same thing. This is like the CI job, the CI file of the project already has a SAST included, template included. And our policy will still run its own job, even if there's an existing similar CI job in the local CI of the project. Now, the way you can avoid duplicates is to disable certain just by setting a CI variable, SAST disable, dast disable is equal to false, and so on. So that way, within the local project, the SAST or the job is not executed, but the one from the policy cannot be stopped to be executed. Now, then you see the whole thing executes, and we have down to deploy job. These are just some of the jobs that the local CI job of the CI template file of the project has. Now let's go back to our secure. This is scan execution policy. Now let's now create scan result policy. But first, let's see our security dashboard. If we go to, let's see, vulnerability reports. If we come to vulnerability reports here, we'll see that it has secret detection has detected, the secret detection that we added has detected a vulnerability. And this vulnerability, let's see. Password is included in the URL. So you can either create an issue for this to be treated or add an existing issue and escalate to the team. Now, then let's create a scan result policy for now let's go to edit, new policy, then scan result policy. Now within the scan result policy, it's similar, but the only difference is in the rules and the actions. Also, you can only create a maximum of 5 rules. So test result policy. So it's enabled. Then we will now say anytime there's a security scan and you can either select all or you can say, oh, secret detection, and it runs against all protected branches and it finds any vulnerability that match the following criteria. Either a new severity of, let's say, let's select all except this, or maybe you can a new status previously existing. That means the secret is previously existing and it's let's select all, but it's not resolved. The state of the vulnerability is not resolved, but it has discovered it again, but not resolved. Then what action should it take? It should require approval. How many approval? We can set the number of approvals required. Let's leave 1 approval from, you can either specify a role, or you can specify individuals, or you can specify a group. So you can maybe select a group, or you specify a role, a developer, a maintainer, an owner, or you can specify individuals. Within individuals, you can specify, okay, let's say for example, I select Michael. You see, this is what the rule looks like. Now, so let me then configure this rule. So it creates a second merge request in the same security policy project that we have already. Now, let's see the changes it's introducing. Okay, now it's adding to the same policy file. So let me merge, merge. Done. So let's go back to our project. If we go back to the file, let's say code repository, and I look at our policies here, the policy file, then you see here we have our scan execution policy, then we have our scan result policy. Now let's go back to our project. In our project, let me create, let me make some changes to our application. Let me open the web IDE, and let's say I just make a small change, application, views, and welcome, and I say hello. Instead of hello Rails, let's just say hello GitLab. And here I will specify, okay, welcome GitLab. Then instead of committing to master, I want to commit to a new branch. Now I can specify the name of my branch, or I can leave it empty and just hit enter to use any name. Now it has done the commit, then I'll create a merge request. Now within my merge requests, welcome GitLab MR, and I assign myself, and yeah, it should delete the source branch. Now let's create a merge request. Now as it's running, you see it has shown here that it requires one approval from test result policy, and that approval is here, 0 of 1. So and it has shown DNS Michi, Michael's name here. It's my teammate. So it's going to run all those tests, and it's going to run against also secret detection. Oh, I think I need to make a change. Our secret detection didn't show up here because our scan execution policy only runs against protected branches. So let me change the policy, edit policy, and instead of only protected branches, for now I'm going to put it to all branches, including our MR branches. Now let's configure this to create a merge request for us to update. And now this is what we are changing. Instead of protected, we are changing it to all. Now, then merge. Now, once we merge, let me go back to my project and select here. Okay, let's see my merge request, and we have this. So this is still running. So now we can see here, one of the things that we have, a GitLab security bot is created anytime a security policy is created against a project. Now, and here is showing us that a policy violation has occurred. Now, security and compliance scanners enforced by organization have completed and identified that approvals are required due to one or more policy violations. Review policies rules. And this is because there's a job that needs to be executed that didn't. So in this case, either you review the rules. In our case here, I've already fixed the issue. Now let's close this MR and introduce a new MR. Then let's say I can, probably make this again and put an exclamation. Then we create welcome GitLab on a new MR, but on a new branch, for example. Then let's create a merge request to master. I assign myself, and yep. So here now we should see that, yep, it now includes all the other jobs: secret detection, SEMGREP, SAST, and so on. Now, also, like I mentioned earlier, you can remove duplicate jobs. That instead of the SAST scans to be executed from the policy and also from the local CI configuration, we can disable that of the local project. And we can do that by coming to our CI. Let's say here, we go to our CI file and we say, we can specify a variable SAST disable. But first, let's look at our job here. Okay, it's executing, and let's see, it's almost done. We can come under variables to create a variable. Let's say we have our variable here, SAST disabled. Now, let's wait for this to finish before we start another job. Okay, it's almost done. Unit test job, and so on. Now, before this is done, one of the things you need to be aware of are additional approval is required. One of the issues we encountered in the previous MR that we had, when a scan policy is removed for whatever reason, a scan that is supposed to happen didn't happen, but is expected by the policy. Now, maybe someone stops a security job. There's a security job that needs to be executed, but for whatever reason it was stopped. Approval will be required before the merge request can proceed. Now, and also if there's a manual job that blocks the rest of the CI, an approval is required before it proceeds. So it will not proceed until an approval is given before the rest can be completed. Now, if we see here, the security bot has already mentioned that, okay, there are policy violations, and which needs to be fixed by an approval. One of approval is from DNS Michi, but our CI is still running. Oh, our CI has finished executing. So let me refresh and see what is the violation. Now, security scanning detected no new potential vulnerabilities. So I'll be introducing, let's see, a small vulnerability. So let's say let's add dot env dash sample, then I add API key is equal to so let me put an AWS key, a sample. Let's just say AWS key, then AWS underscore secret. Then I can put any secret here. Now, then let's submit an MR. Now here we can say add key. Then let's commit to a new branch and press enter. Then we'll create an MR. So we added key. Let me assign this to myself and create a merge request. So this is going to run. Now you see first it says until everyone approves. This is not going to proceed. Then once the job is done, we'll see here that there are no duplicates of SAST job this time. We only have SAST 0, SAST 0, SAST 0. There's no SAST 1 because we added the SAT underscore disabled. So that is how you avoid duplicate jobs. Now, so once this is executed and done, we'll be able to check the security vulnerabilities that's been generated by the CI. So let's view the pipeline and see, okay, what are the things. Okay, it's still running the last job. Now, for scan result policy, the rules are only evaluated after the job has been completed. The CI scan and the CI jobs have been completed. That is when it evaluates and checks, okay, has this policy been violated? Has that policy been violated? And the results are displayed in the MR. Okay, let's see, our pipeline is almost done. Okay, this is loading. It's almost done. Once it's done, it will display our CI results here. Now, we can see here that it's showing that we have one critical, we have a new vulnerability. And what's the vulnerability? Critical AWS access token. Because I added a sample token there, I just got it from Google somewhere. So if we click here, and you see here it's showing that you can resolve with security training. Okay, for security token to be exposed, probably need more trainings for the developers. Then we can enable security training, which is a feature of GitLab, or you can also come to review, oh, what happened? Where was the secret exposed? This was where it was exposed, and you can create an issue to resolve it. Yeah, that is how you can set up security policies in GitLab. Like we said, you can set up security execution policy or security result policy. Thank you.